Good day, class. So this is in continuation sa ato ang discussion sa past diffusion model, and I just like to recall or recap on the things that we discussed last time. So this equation here, boxed in red, we derived this one during our class, and this equation tells us that this equation represents the probability of a product being adapted at a given period of time. So it is given by n of t, where n of t is the number of new adapters in time t, and this is equal to this expression. And if maka-recall mo, this equation looks familiar because this resembles the polynomial equation. Okay, so where P is the coefficient of innovation, Q is the coefficient of imitation, M is for the market size, A of T is the cumulative number of adoptions given by the summation of N of T, where T runs from 1 up to T minus 1. Okay, and R is your remaining market, where R is just equal to M minus A. Okay, so when we have that equation, kanang polynomial equation man na siya, so it is actually a polynomial equation of order 2. Okay, so we can actually use general nonlinear least square method in modeling actual data, okay, which will be part of your problem set na. So I will upload that one. So in your problem set, you will be given a certain data, and from that data, you should be able to get the coefficient of innovation and the coefficient of imitation based on the data. And and for you to determine those coefficients, you need to fit the actual data with this model, kaning equation. Okay, this equation. So ano lang siya? General nonlinear least square method. You can use any software that you like. You can use Python, or you can just use MATLAB. Anyway, naka-discuss naman tayo before of nonlinear fit using MATLAB. Okay, let's try to make a simple program wherein ma-demonstrate na to ang kaninga equation. This is what we call a discrete bus model, and we'll try to make some graph wherein atong i-vary ang coefficient of innovation P and Q. So unsa ka ang nindot ka combination, mas dako pa dapat ang P, mas dako pa dapat ang Q, para ang imuhang number of new adoptions will be very, kumbaga, mas pabor siya sa inyo, wherein mas daghan ang mo-adapt sa certain product at a shorter amount of time, such a way nga paspas ang adoption sa product. Or it could be nga if combination nimo sa P and Q, dugay kaayo mo plato ang product, meaning dugay po siya i-adapt sa market. Okay, so let's open up MATLAB. Okay, so we have this one. Let's create a new file or a new script, and we'll call this discrete bus model, or DBM. Okay, so if you recall sa to ang MATLAB exercise before, when we create a program, it is important nga magbutang kadaan o what you call this, documentation, para ma-keep track ng imuhang program para if gamito na imong program in the future, should be able to recognize or maka-understand ka unsa na imong program all about. Okay, so the file name of this is dbm.m. Okay. Of course, ang author. That's me. And description demonstrates the discrete bus model. I think okay na siya. Okay, mag-create ta og function sa kaninga program. So we have function dbm. Okay, and ang input niya kay PNQ. Okay, so we have this one. So ito i-endaan. So mag-create ta og x and y nga axis. So for the x-axis, we have our time nga axis. Okay, and ang time is, let's say, for a total of, let's say, 30. Let's say, ang iyang unit ana siya kay in years. So, it could be 30 years. And our market size is, let's say, 100 para simple siya. And, mo create man ta og basta itong equation kay duha man to ka values ang ato ang, let's say, interested ta i-measure. You have the A of t. In this case, we have the N of t or the A of t. Okay? A of t is just the cumulative sum sa imuhang mga adaptions where ang N is katong new adaptions. Kung sa ano pa na siya sa COVID cases, ang kanang N is new cases. Okay? Mga bagong cases per day. Ang A is total cases. So sa bus model, N is the new adaptions and A is the total adoptions a given time. Okay, so this is A of t. So ato siyang i-initialize. So butangan na to siya o 0 values siya. Kaya ato siyang initialize. You have zeros na function. So we have this is one row, and that's 30 minus 1, that's 29 ka columns. Okay, and also for our N of t, we have zeros, 1, okay, then our initial value sa N of t, so we have N of 1 is 0, so wala pa kay new adaptions. Then we'll create or we'll make a for loop, okay, for I starting 2, okay, for I equals 2, okay, ang 1 man is 0 up to time. Okay, so we can then provide two values for we have A of t and the N of t. For the A of t, so we have, this is A of I. Summation na naman doon siya, diba? We have sum of from 1 up to, so this is N. N is summation sa N from 1 up to I minus 1. Okay? And ang n is kani nga equation. Kani nga equation, right? So, kani siya. So, when we go back sa ato ang program, we'll write that equation. That would be P times M plus Q minus P times A of I minus, so we have Q over M times A of I square. Okay, so muna to ang equation. Then we'll go ahead and plot this, plot the results. So we have hold on, we have plot, plot A. Let's say ang color sa plot A would be, say, black. Then plot N, ang color niya is red. Okay. So let's try to run this one. Okay, so let's say ito siyang i-plot, and ang ato ang it's actually nag-create man tani pa function man siya, and ang input niya is P and Q. So let's say ang atong gusto kaon is ang P is 0.03, sample lang na siya, and ang Q is say 0.38. Oops, error is, let's go back to the program. Asa ni dapat? Sorry. This is yeah, error na siya. So going back sa ato ang command. Okay, so dpm P is 0.03, Q is 0.38. Okay, so ang plot is tara ang plot. Okay, ako siya i-click. Okay, so sama na siya. Take note nga ang awat na nakabutang og legend, no? Ato lang siyang run balik. Going back sa to ang program here. Let's say magbuhatag input din he, and this is dili lang. Legend. So this is A of T. And this is N of T. Okay, so this is the plot. Okay, so in which mo make sense here, right? And ang graph sa kaning n, which is cumulative, okay? So this is n is new adoptions, I mean. So n is new adoptions. You will see nga based sa equation, it will say sugod mo rise siya, musaka until such time nga mo abot siya sa peak. Then there's such abot ang time nga mo naog na ang iyahang number of adoptions over time until wala na mo adapt sa product. So similar po na siya in parallel siya sa behavior po sa A of t, which is the cumulative adoption. So ang total number of adoptions is ang behavior na sinani musaka siya at earlier time. Then mabot ang time nga mohinay ang iyahang increase until such time nga mo plateau na, meaning constant na ang total niya is constant. So wala na nadugang nga mga new adoptions, which is mo parallel siya sa ubos, which is sa kaning red. If ni zero na ang new adoptions, so ang total baka cumulative ni mga sum sa imuhang adoptions is mo plateau siya, so meaning wala na na-add. Okay, so let's try to observe the behavior of this figure when we try to change some parameters. Okay, so let's say ato ang i-plot lang is ang total cumulative. Okay, and we'll compare. Let's go back sa ato ang program. So ato sang i-comment ang n because we want nga ang i-display lang niya is ang i-plot lang niya is ang a, not the n. So kana siya. Okay, so mag-change man taog. Okay. Let's say mga output na to is lahi nga color. So anong bubutang ta another input which is say color input. Okay. So this would be color input. Yeah. Okay. Then nabutang tag legend. Okay, I'll try to run this one if okay ni. So let's say mag-start na nga ang value sa P is 0.05 and ang Q kay 0.001. Okay, let me fix the error first. Wala na nagbutang og color input. Okay. This one na tay color nga say black. Oops. Okay, so muna iyang gawas. But natay mali warning lang sa iyang legend, wala ni gawas ang Q nga value. Anyway, we'll try to figure that out kung saan siya pag correct. Let's go back sa itong program. I think kani siya. So try to run it again. Okay, that's correct. Okay, so we have wala ni gawas ang space. Well, anyway, so that's a P and a Q. So ito na siyang polish. Balik ta sa ato ang program. Okay, so this would be P equals that one. Tingnan na siya. Okay, that would be the case, and okay, we'll try to run it again. Oops, balik ta. Okay, wala siya naputangan og kama. Na. Okay, let's take a look at our program. Okay, that is better. So that is the graph for this is A of t ni siya. So that would be this one, A of t. So kana siya ang P is 0.05, ang Q is 0.001. So let's add another graph wherein ang value sa P is 0.1. Let's say 0.1 and 0.1 put ang Q. Okay, so this would be red. Okay, then another. So this time 0.001 ang P. Then ang Q kay mas dako, we have 0.5. So this would be color blue. Then lastly, ang P na to is 0.001 and ang imuhang ato ang Q is 0.25. Color is so pala yung color na bilhin. Yellow. Okay, if we look at the graph, so makita ninyo ang behavior, right? Lahi siya. And asa man diri ang advantage, okay? Asa diri ang medyo disadvantage nga model, okay? So makita nyo din nga ang kaning color red is mas nindot siya because at a shorter time, let's say less than 5 years, daghan na ang iyahang total adoptions, which is ang y-axis na to is A man na total adoptions. Okay, mas daghan ang iyahang adoptions in shorter period of time, and niplato siya somewhere here around 25 years. So technically mas nindot ang iyahang performance kay taas ang iyahang number of adoptions, mas daghan. Compare nimo sa kaning color black na dili kaayo, how much more sa kaning color blue, dugay kay siya ni saka ang ihang number, dugay kay gi-adapt ang product. Okay, let's say it took this one around 10 to 15 years aya pa ni sugod og daghan ang number of adoptions. How much more kaning color yellow, which is wala na butang ang legend. Anyway, how much more ang kaning yellow, wherein so mga 20 years gid siya aya ni skyrocket ang iyang sales o ni-adapt ang mga tao sa kanang certain product. All of which nag-differ ang iyang behavior because naglahi ang imuhang values sa P and Q, meaning the number coefficient of innovation and the coefficient of imitation. Sa kaning red, mo ni siya ang 0.05 nga imitation. Okay? 0.05 nga innovation and 0.001 nga imitation. So, sa upat, kani siya ang in between ang iyahang nasa tunga-tunga ang iyahang coefficient of innovation, and pinakagamay ni siya og coefficient of imitation ang kaning red. So mo na siya ang pinaka-nice performance. In this case, ma-realize na to or ma-observe na to nga mas dali i-adapt ang product regardless of gamay ang iyahang coefficient of imitation for as long as mas dako ang dapat ang iyahang coefficient of innovation. So that would be very helpful and beneficial na information para sa mga mag-create of product na para mas madali nimo, para mas madali ma-adapt ang product sa market. It should be nga dako ang diferensya or mas dako dapat ang coefficient of innovation kato mga influencers, kato mga tawo nga mapalit jud og product regardless of what people say, kaysa sa mga katong coefficient of imitation, which is the larger portion sa imong population. Okay, so that would be the kanisha demonstration sa ato ang discrete bus model. Okay, we have this. You have our program just utilizing this equation kanisiya. So sa inyong problem set, ako na siya i-upload. Tagaan mo data, and then all you have to do is to model it through nonlinear fit, and you should be able to get P and Q. So pabaliktad siya. Sa to example, ang given is P and Q, tapos i-plot na to. Sa inyong assignment or problem set, given mo data na i-plot, you have to calculate P and Q. So pa-backwards here. Which is mo man ang case yun sa modeling. Okay, you are given a data and then you get the P and Q. So once makuha niyo ang P and Q niya, you can do forecasting and prediction at later time. Okay, let's say 20 years from now, 50 years, so may tabo sa imong product. Okay? Would it still be relevant and or mawala na siya? Okay? That would be the importance niya. So, dili lang taman ang kanisa base diffusion model, and sa another model nga itong i-discuss, which is part niya po sa complex system, is the disease spread. So we have the SIR or the SEIR and even the SIRD model. Say, atong itagaan na example is modeling the COVID cases, katong pag-spread sa COVID nga cases. We have data man ana. Okay, we have actual data and we can model it using SIR or SIRD model. So that will be all, and peace.